All right, so yeah, if you're interested, you can have a look at the abstract in your free time there. Project members are all at all at GSC Ottawa, the Near Surface Geophysics Group and Benoit Fauché. We're also collaborating with the Rideau Valley Conservation Authority, the City of Ottawa, and the Ottawa River Keeper. All right, I'm gonna get rid of this. So the reason behind this project is to better understand water exchange in urban watersheds. So a lot of times urban streams get treated in terms of pipe flow. So water comes in over land, it enters the urban stream, and any contaminants that come along with it enter the urban stream, and they basically stay there until the stream enters the main water course. But we know that's not the case. Water and contaminants can reside in these urban systems, and in the case of contaminants, they can stick around long after the source of contamination is gone. So one example is chloride that results that accumulates due to road salt application. And this is a map of from the Ottawa Provincial Groundwater Monitoring Network, and anything in orange and red is basically an elevated chloride level of concern. And so we have sustained or delayed contaminant release that arises due to retention in these urban watersheds, and that can result in a persistent threat to water quality and also to the aquatic ecosystem health. The problem with some of these monitoring data is that they're sparse, both in time and space, and that can limit the understanding of water exchange and storage. So what we want to do is develop or look at electrical geophysical methods for better understanding urban stream settings and the water exchange in these urban stream settings. And the reason we want to use geophysics is that these data can really capture the heterogeneity and the spatial complexity. And we can acquire those data over time so that we can also monitor the system evolution in 2 or 3 dimensions. And we can hopefully track water and potential contaminants as they move in and out of the water and the hyporheic zone and the stream banks. And this would be supported by in-stream data logging and water sampling. So the very first step was site selection. So this is the City of Ottawa. You can see the Ottawa River here. This heavy black line is the intake protection zone for the City of Ottawa. So the water treatment plant we're right around here. And anything in red is designated as a highly vulnerable aquifer. So these are areas of concern. So what we did is we basically walked a lot of these urban streams in the City of Ottawa, looking for sites that were related to these designated highly vulnerable aquifers or to the intake protection zone. And we're also looking for sites that had good access, sites that had indicators for groundwater surface water interaction. And we identified a handful of sites, a few of them along Graham Creek, which is in the west end here. And Graham Creek flows directly into the intake protection zone, so it's of concern for water quality. And we identified a couple of sites on Sawmill Creek in the east end, and Sawmill Creek overlies a highly vulnerable aquifer. There's a thick deposit of highly permeable sediments over a fractured aquifer there. So that site's of interest in terms of groundwater surface water interaction. So once those sites were identified, we entered into negotiations with the City of Ottawa to actually have access to those sites to collect preliminary data. And the idea is that with those preliminary data sets, we'd be able to then select one of those sites for installation of long-term geophysical monitoring equipment. Unfortunately, we didn't get very far in the first year. It took quite a while to reach an agreement, but we now have that agreement in place. And so we're ready to begin preliminary data collection. And that'll be hopefully in June, but definitely sometime this summer. Once we have those data in hand, we'll be able to best select the primary site for longer term installation. And we'll have to start negotiating a second license agreement for our second land use agreement for that site. In conjunction to all that, we've been working on the data workflow because once the installation is up and running, it's going to be delivering a lot of geophysical data, and we really need an efficient way to handle and process all of that. So that's where we currently are. That's my contact information if you have any questions. And Eric, I believe I've got you well ahead of time now.